Hi everyone, my name is Amitesh, and in this video we're going to talk about linear equations. We're going to talk about what is a variable, what are linear equations, and how to solve linear equations. And everything is designed to be super accessible and right from scratch. So let's dive right into it. So the first question we're going to address is, what is a variable? And there are two ways of looking at this topic. What is a variable? The first, which is fundamental from the point of view of linear equations, is a variable represents an unknown quantity. Typically we denote it by a letter such as x. So x is something that we do not know. It's a number, but we want to find out what that number is. But since we don't know it, we just call it x. Now, to be illustrative about an example with this, because this all seems very abstract, is what we can do is we can consider x plus 2 is equal to 8. Okay, this is an equation. Now in this equation, x is our unknown quantity. Okay, so if you don't like x, you can also do it as a fill in the blank problem. You can also do it as blank, which I don't know, plus 2 is equal to 8. What is blank going to be? And so here one way of thinking about it is something plus 2 is 8. The something has to be 2 less than 8. So in other words, the something has to be 6. And if we check, if we fill in the blank here, 6 works as 6 plus 2 is 8. And this is the process of solving an equation. So solving an equation is just saying here that x is equal to 6. Okay, so when x plus 2 is 8, we found that x is equal to 6. So this is one example of variables. Before we know it, we call it x. Once we know it, we call it what we know, what we find it to be by solving an equation. Now, another way of looking at variables, which is also equally important, is variables represent any quantity basically. It can represent any number. So when I write down something like x, or you can write down y, I'm just going to start writing down y as well, just so that you can see that it doesn't really matter what we call it, though x and y are typical. You write down y, this is a quantity. Now if I talk about something like y plus 5, that represents 5 more than my quantity. It's an abstract way of saying that whatever I start with, I'm adding 5 to that, without really saying I start with something specific. And now you can plug in specific values for y. So for example, you could draw a table. So this is an example. You could draw a table. You could say if y is 1, then what is y plus 5 going to be? It's going to be 1 plus 5, which is 6. If y is 2, then what is y plus 5 going to be? Well, it's going to be 2 plus 5, which is 7. And you can keep going. So if y is something like, you can do any number. If y is minus 3, what is y plus 5 going to be? It's going to be minus 3 plus 5, which is 5 minus 3, which is equal to 2. So in some sense, this y and y plus 5 is representing a range of outcomes. Instead of tabulating all of these and saying, 1, 6, 2, 7, negative 3, 2, we're just going to say y and y plus 5. That represents the idea of adding 5 to whatever we have. So that's another way of looking at variables. And it's cool that once you have introduced this idea of looking at variables this way, you can play around with them and add them and do other stuff with them. So for example, here I've talked about y plus 5, but I can also talk about something like y plus y. What is y plus y going to be? It's always y more than y. So here, this is a bit different. So two ways of thinking about it. One way of thinking about it is think about bananas. Suppose I have one banana and then I have another banana that you gave me. How many bananas do I have? I'm going to have 2 bananas, right? So y, you can think of it as an abstract quantity, can represent a banana. One banana plus another banana is going to be 2 bananas. So we write y plus y is going to be 2y. Now when I say 2y, what I really mean is 2 times y. And another way of looking at it is whatever y is, if you add it to itself, it's the same as multiplying it by 2. 5 plus 5 is equal to 10, which is 2 times 5. 3 plus 3 is equal to 6, which is 2 times 3. So really I should put a times here. But in math, what we do is we don't put a times here because we understand that's there and it just adds on an extra symbol. And this is possible because we're dealing with variables. You know, if I had something like 2 times 5 and I said it's 2, 5, that would be complete nonsense because that doesn't make any sense, you know. So this would not work. However, because in this case y is a variable, 2y is understood to be 2 times y, we don't have to worry about that. So this is a mathematical shorthand for 2 times y is 2y. Okay, so I'm going to erase that here. And we can keep going. So I encourage you to think about this. What is 3y plus 2y going to be? 3y plus 2y. So again, 3 lots of something plus 2 lots of something. If you like, 3 bananas and 2 bananas. How many bananas do I have? I have 5 bananas. So I would write 3y plus 2y is equal to 5y. It's very important I do not just write 5. 3y plus 2y is not just 5. You have to put the y, just like in the banana example. You wouldn't say that 3 bananas plus 2 bananas is 5. Right? That is not taking into account an important information, which is the bananas. It's going to be 5 bananas. So here you have 3y plus 2y is equal to 5y. Okay, so that's how we write this. And it's all the same. You know, you just have the extra y there, which you shouldn't forget. But otherwise, you can do other stuff. You can talk about what is 3y minus 2y. What do you think 3y minus 2y is going to be? Well, 3y minus 2y is just going to equal to, well, 3 lots of something minus 2 lots of something is going to be 1 lot of that thing. 3 bananas minus 2 bananas is going to be 1 banana. So it's just going to be 1y. And this is another point where instead of writing 1y, we just write y. It is understood that there is only one of it if we just write a single y, just like in this example that we've done here with the y plus y. It was really understood that there is a 1 here, but we just don't include it. So again, this is a mathematical shorthand. Just like abbreviations, you know, that you have like when you text message, you know, like you say LOL, you don't say laugh out loud. So that's an example where you just take an abbreviation, it's understood that this is y, and this saves space. This saves time and space that instead of writing out the 1 every time. Okay, so we have 3y minus 2y is equal to y. Okay, so we've got that. Now, this is where another point of variables, that y represents any quantity. And so because it represents any quantity, you know, these equations are true for any y, which is really cool. If I put y is 7, it's just saying 7 plus 7 is 2 times 7, which is fine. If I put y is 3 here, it's 3 times 3 plus 2 times 3 is 5 times 3. Okay, so these are universal rules. No matter what y is, this is true. All right. Okay, so now let's talk about linear equations. So we sort of talked about what variables are. This is designed to be a quick introduction to variables. We're now going to talk about linear equations. So what are linear equations? We've already seen an example of a linear equation. So linear equations are just going to be something like, for example, we just talked about x plus, something like this, x plus 3 is equal to 10. Right? This is an example of a linear equation. There are more examples, but I'm just going to gradually go up. So in this equation, the question is always solve for x. That's always understood. When you have an equation like this, what is x going to be? So you wouldn't say that solve for y here, because this is just a general law. It's true for all y. So there is no one value of y for which this is true, because every y has this property. But here, there is only one x that has this property. So you can ask solve for x. And in this equation, you say x plus 3 equals 10. So 3 more than something is 10. What is the something? The something has to be 3 less than 10. So you would say x is equal to 7, which is equal to, another way of writing that to do it in 2 steps, is you can say that it's equal to 10 minus 3, which is equal to 7. Okay, so that's one example. Now, there are other examples of linear equations. So I'm going to do one more. So what if you write something like, and you can use any letter you like. You can use x, you can use y. These are the most common. When you start running out of letters, you start using z, etc. But you can sort of start by, let's say, use z here. So maybe I'll not use z because it looks like 2. Let me use y. 2 times y plus, let's say plus 5 is equal to 11. Okay, so this is slightly more one level up. In this example, what we have to do is we have to think about it the same way as we did the previous case. 2 times y plus 5 is 11, right? So what we do is we do it in 2 steps. First we find out what is the 2 times y. Then we find out what is y going to be. Okay, so something plus 5 is 11. The something is 2 times y. What is the something going to be? Well, if something plus 5 is 11, the something is going to be 5 less than 11. So 11 take away 5, which is 6. So one way of writing that is 2 times y is going to equal to 11 minus 5, which is 6. Now 2 times something, so I can write this out in one more step. 2 times y is equal to 6. 2 times something is 6. What is the something? The something is going to be 6 divided by 2, because 6 divided by 2 is the thing you multiply with 2 to get 6. So this is going to be y is going to equal to 3. And this dot 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 sign I've denoted there is a therefore sign. It's a maths terminology. It just means we have concluded that y is equal to 3. Okay, so we've got that. Now that's an example of solving an equation. These are linear equations. Something times a variable plus something else is equal to a third thing, whatever that is. Okay, and the point is there is only one variable in the equation. You don't have y plus y. I mean, you can have y plus y and just say it's 2y, but to be precise, I'm just going to show you some examples of linear equations and just write them out. So for example, 3x plus 8 equals to 11. That's an example of a linear equation. 4x minus 2 is equal to 18. That's an example of a linear equation. It's always something x plus something, which could be minus something, equals to something else. Okay, and there could be negatives involved. Okay, so there could be negatives, so you could have like, minus 2x minus 4 is equal to, for example, minus 6. Right, that's an example of a linear equation. Or you could even have fractions. So for example, you could have a fraction like 1/2 x plus 4 is equal to 6. And that's also a linear equation. So linear equations are things which look like something times x plus something equals something else, and these something else's something something. So I'm calling them something, which is kind of sounding a little confusing, but I'm going to underline them. These are what are called constants in the equation. So x is a variable. This minus 2, this minus 4, this minus 6, this 6, 4, 1/2. These are called constants. Okay, so they are known, they are specified, and the thing we want to find is the variable which is not specified. Okay, so we have constants and variables. So these are, I'm going to write them as constants. All right, so why don't we dive right in and finish the video by solving all these equations to just give an idea of how it works. So the process is the following. So I'm just going to write this out. So the process is, there are 2 ways I like to do it. One is, you can just think about it intuitively. Another is there is a step-by-step process. They're both the same, but we can do it one by one. So 3x plus 8 is 11. What we like to say in this case is we can subtract 8 from both sides. Okay, so what does that mean? So when I think about this equation, 3x plus 8 is 11, okay, you're thinking about it, you know that 3x plus 8 is 11 is the same as saying that 3x is 8 less than 11. So you want something that adds with 8 to be 11, the thing should be 8 less than 11. In other words, 11 minus 8. This is the process of subtracting 8 from both sides. So when you have an equation like this, what you can do is you can say that 3x plus 8 minus 8 equals to 11 minus 8. All we're doing is we're saying the two numbers are equal. Therefore, if you subtract 8 from both the numbers, they still remain equal. Okay, so in this case, you're just going to say that because this is true, 8 minus 8 is 0. And the reason I've subtracted the 8 is to get rid of that so the equation looks simpler and I just have the 3x. And that's what we're going to get. We're just going to have the 3x. and we're going to say 3x is equal to 11 minus 8, which is equal to 3. So therefore we have 3x is equal to 3. Now when we have 3x is equal to 3, we know 3 times something is equal to 3. What is the something going to be? So the something would be, I want you to think about this while I'm asking, as I'm talking, something is going to be 1, right? But another way of looking at it is you can say that because two things are equal, you can divide both sides by 3. Okay, so what that looks like is you say that 3x divided by 3 is equal to 3 divided by 3. Now 3x is going to be 3 times x. So just like with fractions, when you have 3 times something on the numerator and 3 on the denominator, you can cancel off the 3's on top and bottom, and you're just going to get the something which is left over, which is x, and x is going to equal to 3 over 3, which is 1. So why I sort of talked about this is this process is kind of what you're doing, but you're doing it in your head, but really what we're doing is we're inverting the operations. So when you say 3x plus 8 is 11, we're inverting addition to say that something plus 8 is 11, therefore the something is 11 minus 8, minus being the inverse of addition. And then we have 3x is 3, we're saying 3 times something is 3, the inverse of multiplication is division, so we're saying that something has to be 3 over 3. Okay, so let's do another example. So 4x minus 2 is 18. If it's not, if you have questions, as we do more examples, you'll see the process is the same each time. It's just the numbers are kind of different. Okay, so the next process is going to be 4x minus 2 is equal to 18. Solve for x. Okay, so that's always the question. What is x going to be? So again, you think about it, 4x is something, 4 times something we don't know. Minus 2 is 18. So something minus 2 is 18, the something being 4x. That means that the something is 2 more than 18. To subtract 2 to get 18, your thing has to be 2 more than 18. So therefore, 4x is going to equal to, so this is a process of adding 2 on both sides. So I'm just saying that being 2 more than 18 is being 20, but I'm writing this in this way because it's the same thing, it's just showing your work as you're solving the problem. You're basically saying when you add 2 on both sides, you're saying that two things are equal, therefore if I add 2 to both of them, they still remain equal. And what that does is it gets rid of the minus 2 and just leaves you a 4x. So you have made your thing simpler. This is the idea of problem solving, is you make things simpler at every step. Get closer to the solution. 4 times x is 20. So again, think about it in 2 ways. 4 times something is 20. What is the something going to be? Right? The something is going to be 20 divided by 4, because that is the thing that you multiply with 4 to get 20. Okay, so something is 20 divided by 4, and another way of writing that is 4x is 20, so if you divide 4x by 4 and if you divide 20 by 4, you get the same answer. Two numbers are equal, you divide them both by 4, you're going to get two numbers that are again equal. So here you're going to get 4x over 4 is 20 over 4, which is then going to mean that 4 times something over 4, fractions, you cancel the 4 from top and bottom, you're going to get x is equal to 5. So 20 over 4 is 5. So that's going to be the answer there, so x is 5. All right. Okay, so that's an example of that equation we've solved. Now we have some negative signs, so I'm going to play around with this. All right, so the next equation is going to be minus 2x minus 4 is equal to minus 6. So you may ask when you see this, what is minus 2x? I mean, we talked about what 2x is. What is minus 2x going to be? So again, just like when you talk about 2x, when you have x represents a quantity, 2x represents twice the quantity. In the same way, when you have a quantity like minus 2x, you're starting off with x, and minus 2x represents minus 2 times that quantity. So if the quantity happened to be 3, it would be minus 2 times 3, which is minus 6. If the quantity happened to be 7, it would be minus 2 times 7, which is minus 14. The point is that x is not known, so this is just representing minus 2 times what we don't know, and now we want to find what it is. Okay, so we have minus 2x minus 4 is minus 6. we have to be careful with the minus signs. This is the first step with these equations to get a feel for. I mean, even though you can do maths for years and years, and it's easy to mess up the minus signs. Certainly happens to me, happens to practicing mathematicians, research mathematicians, happen to anyone. So you just have to be careful here. So minus 2 times x minus 4 is negative 6. So again, we want to get rid of the negative 4. So what do we do to both sides of the equation? We add 4, because negative 4 plus 4 is 0. Okay, so here we have minus 2x minus 4 plus 4 is equal to minus 6 plus 4. The point is that adding 4 to both sides of an equation will keep a new equation, because if two things are equal, you can add 4 to both sides of that equation and the two new things will still be equal, because something is equal to something. You add 4 to both the somethings, you get the same thing. You get the same things back. So here you have this. Now minus 4 plus 4 is 0, so you get minus 2x is equal to minus 6 plus 4, which is equal to negative 2. So minus 2x is equal to negative 2. Now here I've sort of bypassed. Earlier I used to say that minus 2x minus 4 is negative 6, therefore minus 2x is 4 more than negative 6, and that means minus 2x is negative 2. But I didn't repeat that this time, or I just did, but I didn't repeat it before doing the process, because I just want to show you that you can follow the process to solve these equations. You don't have to always think backwards. You just think, how do I eliminate the minus 4? I add 4 to both sides. Okay, so I've done that. Now I get minus 2x is negative 2, which is already looking much simpler. And now I've got that. Well, what do I want to do? Well, again, instead of thinking about the process of backwards, like minus 2 times something is negative 2, what is the something? Let's do a process to get rid of the minus 2. So how do we get rid of the minus 2? Well, this time, because we have a minus, you want to divide both sides by minus 2. Okay, so two things are equal, you divide them by minus 2, they'll still be equal. So you've got this equation now, and again it's the same idea. The negative signs just cancel. It doesn't matter when you have minus 2 times something by minus 2, it's just going to be the something. Just like any other fraction, you're going to get x is going to equal to minus 2 over minus 2 is 1. So x is 1. Okay, so I'm just going to put the solution. So in this case, we're going to have x is 1. In this case, we're going to have x is 5. And in this case, we found x is 1. And once you get the hang of it, you can start solving these in your head also pretty quickly. You can just go through the process. But in the beginning, it just takes some time. Just make sure you follow the process, and then when you get really confident with it, you can just do it very fast. Okay, so last equation before we finish is going to be the following, and this is going to involve a fraction, so it may give you some idea of how these things work. So we're going to have half x plus 4 equals 6. So what's going to happen here? So half x plus 4 equals to 6. So again, step by step, you want to isolate. What we have been doing so far is isolating the x. We are getting rid of the decorations on the left hand side. The decorations being the half and the 4, the constants. Something times x plus something is 6. What are we going to do? We're going to make it just something times x is something. Then what we're going to do, just say it's x equals something. Okay, so we're going to systematically do these steps to invert what we have here, which is half x plus 4. When we have half x plus 4, we can subtract 4 from both sides to get rid of the 4 on the left hand side. So that's going to be the same as saying half x is equal to 2. Now what should we do to both sides? When you have on the left hand side half x and you just want to isolate an x. So when you have half of something, how do you get back the something when you have half of something? What do you have to multiply the something by to get back the something? When you have half times something, you want to multiply the something by 2. Okay, so it's just like clearing denominators with fractions. You just want to multiply. You don't know what the something is, but you know that if you multiply 2 times half, you get 1. And you know that half x is representing half times x. Okay, just like 2x is representing 2 times x. Okay, so here we're going to get, this is going to be 2 times 2. So we have to multiply both sides by that quantity, which always remember, two things are equal. You can multiply both sides of the equation by the same thing, and they will still be equal. But you have to remember to do that to both sides. Sometimes it's easy to forget, and then you get the wrong answer. Okay, so 2 times half x is 2 times 2. So therefore x, 2 times half is 1. 2 and 2 cancel off. So therefore x is equal to 4. So in all our solutions, x was nice. As in, it was like 1, 5, 4. X could also be a negative number. Sometimes solving equations, x could be a fraction. I'm not doing those in this video. I just wanted to introduce you to the basic principles. I will likely do a second video, in which case the link will be down in the description, where I will talk in more detail about some more examples of linear equations, solving them, where the solutions aren't necessarily as nice. But that's a thorough introduction to what is a variable, what is a linear equation, and how to solve them. You can find lots of resources online, examples of equations. You can write down your own. You don't have to even go online. You can just write down, think of any numbers. Here I've just came up with these on the spot. It's not that I prepared these. I just while I was talking, I just wrote some down. You can also do the same. You can just write 5x minus 7 is 11. What is x? Your answer may not be nice. It may be a fraction, depending on what you use. But you still get the process, and you sort of think about what happens. And if you have any questions, leave a comment down below. I'd love to read your comments, and I'll do my best to reply to as many as possible, but I'll read all of them. And if you love this video, please like and subscribe. It would mean a lot to me. Help me to grow my channel, because my goal is to really reach as many people as possible. I want to create free, accessible math education worldwide. I just want to, in my room, talking on a whiteboard, I want to disseminate math so anyone can just learn and understand and be inspired. And if you like and subscribe, it really helps to disseminate my videos to other people. So thank you so much. I hope you love this video, and wherever you are in the world, I hope you have a wonderful day, evening, night, and I'm super excited to see you in the next video. And if you subscribe, you'll keep up to date with all my future videos. And I really look forward to seeing you again, either in the comments or in future videos. And I wish you all the best. See you soon.